So we're now going to prove the summation rule for the derivative. So it's basically d dx of f of x plus g of x. And well, if you want, I could write out the formula here, which would just be that this is equal to the derivative of him plus the derivative of him. But when you prove this rule, or you prove the product rule, which is slightly harder, or the quotient rule, a point is that we don't actually need to know the answer a priori. This is more or less something where you can feel your way forward to the answer. So let's just now apply the definition of the derivative. So at this point, I mean, we don't know much about the derivative of two general functions. We just know the definition. So let's plug it in. So we get here lim h goes to 0, and then f of x plus h plus g of x plus h minus the value at x here. Then all of this divided by h. And now what can I do? Well, now this has turned into an exercise on using the rulebook for limits. Yay! As with any proof of any of these rules in the rulebook for the derivative. And now what can I do? Well, so the only thing that seems reasonable for me to do is to move terms around so that the f's are moved together and the g's are moved together. So let's do this. And all of this over h. And now I can notice that, well, gee whiz, if I move h here separately and here separately, this certainly looks like, so let's do it just erasing here. So this certainly looks like something that's familiar. The limit of this would then just be the derivative of f at x, and the limit of this guy would just be the derivative of g at x. So what can we do? So now we need to kind of point out that the assumption here in the rulebook is that f derivative at x and g derivative at x both exist. So this I'm given. This is an assumption. Aha. So this guy has a limit and this guy has a limit. So then I can now use the summation rule for the limit of functions and say that, well, if the limit of this and this exists, then I can split this up like this. And now, well, this is just the derivative of f, and this is just the derivative of g. So this thing here is equal to that, provided that both f and g have derivatives at x. And we are done.